Hi, ladies and gentlemen. We've got here Mr. Said Kauhor.
No, it's actually a site, yes, done.
Well, alright, Said, demonstrate us what this application you got here actually does.
Well, guys, what you see here is just an Android tablet, but it's special in this sense that you can have a remote oscilloscope on it using a PIC32 model, a multimedia extension board that Victor is going to explain you more.
No, I'm not going to explain anything.
No, you have to do
Okay,
it.
fine.
Fine. Okay. What you see here is a function generator, of course. You can know that.
As you can see, I've set the frequency to... Oh, it's not really visible, is it? Anyways, it says 52 Hertz, so it's not really a fast oscilloscope. Anyways, it's something.
Yeah.
Carry on.
So, it's basically a very simple oscilloscope. It got all the required functions,
Almost.
such as voltage per division. We have few options here. I'm going to set this on demonstration on 500 millivolts, or even maybe less, or more, 1 volt, because we have a 2 volt peak to peak on the function generator.
Okay, so you set right now the voltage per division to 1 volt. So
Yes.
each division is basically 1 volt.
Yeah. Then
Okay.
we also have the time base. The lowest speed we can go is 1 millisecond, which is not very fast compared to high-end oscilloscopes, but it's still something, as you said.
Okay.
Yeah, I'm going to set it as 10 milliseconds.
Alright, that's something more sensible.
Yeah,
Quite
it's
so.
getting better and better.
Oh, we
Yeah.
see that actually our application is clipping the actual...
So for solving that, we need to enable the triggering. We also have a trigger menu on this application. I'm enabling the
trigger.
trigger
Okay.
and I set it to 1.5 volts.
1.5.
Yes. Now
I'm
you
sorry
see-
guys if you cannot see this, but the lighting here isn't very good. But you probably get the point. So basically right now we enable triggering.
Yeah.
And continue on.
Well, that's pretty much everything. You can see it works almost as a normal oscilloscope, but with less speed. Anyway, it's quite sufficient for some simple projects. You can use it at home or somewhere else. So let's go to the PIC32. Then after that, we will have a look to the program that runs on the oscilloscope or tablet.
Ooh.
Yeah.
It's like your shenaniganery did something really awful there.
Well, it's not related to this one because
Ho 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 ho, yeah, excuses.
yeah, it was for something else.
Anyways,
Okay, Victor, tell us about your microcontroller. How does it work?
about the microcontroller. Well, it's actually a PIC32 starter kit extension board. As you can see, I got the Ethernet starter kit. And it's connected to PIC32 multimedia board.
Yeah.
But as you can see, there are a lot of features on it, but we use only one of them, and that's this little guy right here.
Oh, the wireless model.
Yes,
Yeah.
this wireless module allows us to connect to a wireless network and basically form a server and use it to collect analog to digital convert samples.
True.
You don't have to do that. Anyways,
Yeah, because there are some girls out there want to see you.
yes, they want to see my beautiful face.
Yes, it is.
But regardless,
Yeah, tell me, what does this router doing here?
oh yeah, the router. Well, remember when I said
Do you
that
have
we
something to
can-
complain to Android guys?
Oh yes, that's quite so. Well, one of the reasons we use a router is we have to form a wireless network in order to connect to the server. And normally that should be allowed on Android using the, oh, what was it called? Ad hoc.
That's not working too.
Yes. Unfortunately, that isn't available on Android, so we had to use more extreme methods. And we form a network with a router, connect to it using our device, then we connect to the device using our tablet, and we draw the data.